Before we dive into the announcement, it's important to understand what particle accelerators are. The Large Hadron Collider, LHC, operated by CERN, is a 17M ring of superconducting magnets and the world's largest and most powerful particle accelerator. It represents the pinnacle of human scientific achievement. In fact, it's so powerful that it can recreate the very conditions of the universe's birth. But could this machine, designed to unlock the secrets of the universe, hold the key to something far more ominous? CERN, founded in 1954, is one of the world's most prestigious research organizations, with 23 member states and thousands of scientists. It's a hub for collaboration and innovation. The LHC is CERN's flagship project, but it's just one part of a vast network of accelerators and experiments. Imagine a racetrack, not for cars or horses, but for subatomic particles in a race against time and space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy of the universe at the time of the Big Bang. The collisions create temperatures 1,000,000 times hotter than the core of the sun. Thousands of magnets guide the protons on their journey, while intricate cooling systems keep the magnets at temperatures colder than outer space. The beams inside the LHC are made to collide at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together, they act as colossal cameras, capturing snapshots of these collisions. Scientists then sift through the debris, looking for signs of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues to the universe's fundamental building blocks. By studying the microcosm, we gain insights into the macrocosm. But with every answer comes a new question, and with every discovery, a new challenge. The LHC is not just a scientific instrument. It's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. Yet, as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding inadvertently unlock forces we cannot control? In the hallowed halls of CERN, where the boundaries of human understanding are constantly pushed, a revelation has emerged that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a voice of authority in the world of particle physics, has recently made an announcement that has left the world both fascinated and fearful. Cox's words resonate with haunting clarity. The goal of CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a miniature version of the very event that gave birth to our universe. The physicist also went on to explain the implications of this goal, highlighting the LHC's extraordinary potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to conjure the very essence of the universe. It's a tantalizing prospect, but one fraught with danger. The mini Big Bang is not just a theoretical concept. It's a tangible reality within the LHC. The temperatures, the pressures, the raw energy, all mimic the conditions of the universe's infancy. It's like standing at the dawn of time, witnessing the birth of existence itself. But with such power comes responsibility, and the question looms, what if something goes wrong? In fact, something did go terribly wrong back in 1978. The Russian physicist Anat Borsky experienced a disaster that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High Energy Physics in Pau, Russia, a malfunction led to his head accidentally coming into the direct path of a proton beam. The beam, with a force that defies comprehension, passed through his skull, entering the back of his head and exiting through his nose. Borsky's experience was otherworldly. He saw a flash brighter than 1,000 suns but felt no pain. The beam's path left a trail of destruction, burning through tissue and bone. Yet, he remained conscious and even walked to the clinic for treatment. The aftermath was both horrifying and fascinating. The beam's path caused localized tissue death, leading to the loss of hearing in one ear and partial facial paralysis. Yet, astonishingly, Borsky's intellectual capabilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy, but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of a particle accelerator like the LHC are not to be taken lightly. The potential for unforeseen reactions, the very fabric of space and time being manipulated, these are not the stuff of science fiction but real concerns voiced by some in the scientific community. One of the most alarming and captivating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, enigmatic entities that lurk in the shadows of our universe. The idea that the LHC could create such an entity, even on a microscopic scale, is shocking to both the general public and experts alike. Could this black hole grow uncontrollably, swallowing the Earth from within? Though scientists at CERN have assured that any black hole created would be unstable and evaporate almost instantly, the mere possibility has ignited debates, fears, and a sense of awe at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy released is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight and then a heavy weight is dropped onto it. The fabric bends and curves, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. That's a simplistic metaphor for what could happen in the LHC. In the world of quantum physics, where the rules of the universe are both bizarre and beautiful, there exists a theory that extra dimensions may be hidden within our reality. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a microscopic black hole. This enigmatic dance of particles has even caught the attention of some world-famous scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic vacuum decay, a cosmic event that would not only destroy the Earth but the entire universe itself. The esteemed British cosmologist and astrophysicist Sir Martin Rees also expressed his concerns about the experiments conducted at CERN. In his book on the future prospects for humanity, he explored the potential risks associated with particle accelerator experiments, including those at CERN. His words were not merely cautionary. They were tinged with a sense of existential dread. He spoke of a worst-case scenario where an ill-fated experiment could create a condition called vacuum instability. This instability could, in theory, trigger a phase transition that would ripple through the very fabric of spacetime, resulting in a cosmic catastrophe that could engulf the entire universe. Rees's concerns were not limited to theoretical musings. He assigned a probability to these catastrophic outcomes, albeit a low one. But even a minuscule chance, he argued, should give us pause. The stakes are unimaginably high, and the margin for error is razor-thin. The scientists at CERN have calculated the probabilities, run the simulations, and examined the theories to argue for the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of responsible exploration, recognizing that there are widespread fears and concerns surrounding the activities of the LHC. He emphasized that there are rigorous safety measures in place, extensive reviews and protocols that ensure the LHC's operations are conducted with the utmost care. Cox reassured that the energies involved are well within what the Earth naturally encounters, and the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and so unstable that it would evaporate in a flash of energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a fleeting moment of cosmic wonder, a glimpse into the abyss and then gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. This notion, though largely dismissed by the scientific community, has captured the imagination of many and has become a subject of fascination, fear, and even folklore. What lies beyond our reality? Could we inadvertently unleash forces or entities that we do not understand? The idea of opening a portal to hell has even been sensationalized in various media, adding fuel to the fire of uncertainty. But how did this idea come to be, and what does it mean in the context of scientific exploration? The concept of parallel dimensions is not new in physics. String theory, a leading candidate for a unified theory of everything, posits that there may be more than the familiar three dimensions of space and one of time. These extra dimensions could be compactified or hidden from our perception, but they could theoretically be accessed or revealed under extreme conditions. Now imagine the LHC as a cosmic key, unlocking doors that have been sealed since the dawn of time. When protons collide at energies never before achieved on Earth, they could, in theory, create ripples in space-time, allowing us to peer into these hidden dimensions. At the intersection of scientific discovery and popular culture, theories of portals to other worlds have flourished. Books, movies, and TV shows often explore these ideas, from the gateways to hell in horror movies to speculative fiction exploring parallel universes. These narratives resonate with our deepest fears and fantasies, reflecting our desire for knowledge, but also our terror of the unknown. While the scientific community dismisses these ideas as far-fetched, the idea of a portal to another dimension remains an alluring, if unsettling, notion for many. What if, in our pursuit of knowledge, we opened a door that should have remained closed? There is no denying that the Large Hadron Collider represents an unprecedented leap in human understanding. But with this leap comes a responsibility to tread carefully, to acknowledge the uncertainties, and to confront the existential risks that come with exploring the boundaries of the unknown. The search for knowledge is not without its perils, and it is crucial to maintain vigilance as we explore the mysteries of the universe. We must ask ourselves, is the quest for discovery worth the risks? Are we ready for the profound consequences that could arise from our pursuit of cosmic understanding? Only time will tell. The LHC continues its work, unraveling the mysteries of the universe. But as it does, the questions it raises grow ever more complex and profound. In the world of particle physics, where the laws of the universe are bent and twisted, we find ourselves standing on the edge of a precipice. The power to shape the cosmos lies within our reach, but so too does the power to destroy it. The Large Hadron Collider (LHC) continues its groundbreaking work. The possibilities of discovery are both awe-inspiring and terrifying. One of the most intriguing aspects of particle physics is the notion that the LHC's experiments could provide answers to questions that have perplexed humanity for centuries. Among these mysteries is the nature of dark matter. This elusive substance, which is thought to account for approximately 85% of the mass of the universe, has remained undetectable by conventional means. It neither emits nor absorbs light, making it invisible to telescopes. The LHC offers a unique opportunity to probe this unknown realm, searching for new particles that could account for dark matter's presence. But as we edge closer to uncovering the secrets of the universe, the risks remain. The LHC's power extends far beyond anything previously achieved in human experimentation. If the facility were to accidentally create particles or forces that we do not yet comprehend, the consequences could be unpredictable. While many scientists assure the public that all potential risks have been accounted for, there are some aspects of quantum mechanics that remain largely speculative, leaving room for unexpected events to occur. These possibilities, though unlikely, persist in the minds of both the public and researchers alike. Another pressing concern is the creation of strangelets, hypothetical particles that could potentially alter the fabric of matter itself. Strangelets are theorized to have properties that could allow them to convert ordinary matter into strange matter, a much more stable and dense form of matter. If strangelets were created in the LHC and were to interact with the surrounding environment, they could, in theory, trigger a catastrophic transformation of our planet into strange matter, rendering it uninhabitable. Again, this remains highly speculative, and scientists maintain that the conditions required for such an event are virtually impossible to achieve. Still, the mere mention of strangelets invokes a sense of unease among those who study the potential dangers of high-energy physics. In addition to concerns about the physical risks, there are philosophical and ethical questions about humanity's role in manipulating the fundamental forces of nature. With every new discovery, we move closer to a deeper understanding of the universe, but we also gain the power to alter it in ways we might not fully grasp. The creation of mini black holes, the exploration of extra dimensions, or the unlocking of dark matter could have consequences far beyond our current comprehension. The sheer magnitude of these possibilities raises profound ethical questions. Should we be tampering with the very building blocks of existence? What responsibility do we have in ensuring that our experiments do not lead to unintended consequences? Ultimately, the pursuit of knowledge is an essential part of the human experience. The quest to understand the universe is a noble one, and the LHC represents the pinnacle of our scientific ambition. However, this ambition must be tempered with caution and a deep respect for the unknown. As we continue to push the boundaries of what is possible, we must recognize the fragile nature of our existence and the delicate balance between discovery and destruction. The LHC may hold the keys to unlocking the most profound secrets of the cosmos, but it also serves as a reminder that, in the pursuit of knowledge, we must tread carefully.